Hello, and welcome to another segment in Introspect Technology's application video series. My name is Jeffrey Dearden, and I'm an application specialist here at Introspect. Today, we're showing the SV4E frame grabber, a complete solution for characterizing and calibrating MIPI D-Phi and C-Phi image sensors. Here I have an SV4E frame grabber on the left, and a device adapter board with the camera under test connected on the right. The SV4E provides this adapter board with all of the power and control signals required to operate the camera, and it also provides the high-speed integrated MIPI receiver to capture live frames and videos. The connection between the SV4E and the device adapter is via a single high-speed connector interface, as I'm pointing to here. This entire setup can be controlled with Introspect's award-winning software interface, which allows for complete setup and data capture with the press of a button. Let me demonstrate a few of the SV4E frame capture features. To begin, let's take a look at the power-up and initialization of this camera in Introspect software. The image sensor on the SV4E can be configured with easy-to-use settings. In this case, I'll use auto detect for the data rate. The default is 1.5 gigabits per second, and I'll set the format in the image data type to RAW10. The SV4E supports all CSI-2 data types and pixel formats. The parameters shown here are just a subset of the configurations the SV4E can support. So we can connect the SV4E module and then run an initialization on the DUT by selecting one of the preloaded scripts configured and shown here. These scripts are written in Python, and once we've selected one to run, we're ready to receive from the DUT. To begin, let's start streaming live data from the camera. I'll move to the final tab and start. Let's point our camera to our simple setup with a spinning top and watch our stream data on the PC screen. These frames are being captured by our SV4E and camera board and are shown live here in our viewer and software interface. If we want to capture a full set of continuous frames at the full sensor rate, we can use the capture function. For example, here I've set the capture for 20 contiguous frames, and we can scroll through the results in the viewer. All of these frames are downloaded and saved on the PC and are available for post-processing and analysis. Now, the real power of this SV4E frame grabber is the ease with which you can send I2C or I3C commands to the sensor in real time through Python scripts. What I'm going to show you here is a script which exercises the sensor test pattern generators, tests basic functions like vertical and horizontal image flipping, adjusts exposure time and lighting parameters, and controls the gain of the individual color channels within the sensor. All of this in order to test the full camera feature set. So let me start streaming again, and then run a Python script and watch as the SV4E cycles through the camera feature test. And again, all of these frames can be stored for post-analysis. This concludes this demo of the SV4E frame grabber. I want to thank you for joining us today. If you have any questions, please feel free to email us anytime at info@introspect.ca or visit our website at www.introspect.ca.